Permutation. In this lesson, we will tackle circular permutation. When we say circular permutation, it is the arrangement of n objects around a circle. So there are two cases for circular permutation. The first case is about persons or individuals seated around the table, while the second case is about the circular permutation of objects in a chain. In our first example, case 1, let Arnold, Brian, Charlie, and Daryl be seated at a round table. In circular permutation, there is no first and last position, unlike in linear permutation. To determine the number of circular permutations, assume that one object stays in position and let it be the start. In our first permutation, we have Arnold, Brian, Charlie, and Daryl. On our second position, we have Arnold, Brian, Daryl, and Charlie. On the third position, we will have Arnold, Charlie, Brian, and Daryl. Fourth, we have Arnold, Charlie, Daryl, and Brian. In the fifth, we have Arnold, Daryl, Brian, and Charlie. And for the last position, we have Arnold, Daryl, Charlie, and Brian. As you can see, and looking at the list, we can say that there are only 6 different ways of assigning seats to 4 people in a round table. This is because the formula in finding the number of circular permutation around a table and the like is n minus 1 factorial. There are 4 people, so our n is equal to 4. Thus, when we substitute it in our formula, 4 minus 1 factorial is equal now to 3 factorial. And when we expand 3 factorial, we will come up to 3 times 2 times 1, which is equal to 6. Therefore, in the given problem, there are only 6 circular permutations. Let's have the case number 2. In this example, how many ways can a red, blue, orange, and white beads be arranged in a bracelet? In this case, we will also apply the number of circular permutation, n minus 1 factorial. But since the clockwise and counterclockwise rotation would be the same since the bracelet can be flipped, then we divide n minus 1 factorial by 2. So here, you will have the formula n minus 1 factorial over 2. As you can see here, we have 4. Where does this 4 comes from? As you can see in our problem, there is a red, blue, orange, and white beads. This is 4 colors of the beads. Therefore, our n is equal to 4. Therefore, when we substitute it in our formula, we will come up to 4 minus 1 factorial over 2. Then, when we simplify, 3 factorial over 2 is equal now to 3. Thus, there are only 3 distinct ways of arranging 4 different beads in a bracelet. Let us try to have another example. In how many ways can 10 guests be seated around the table? Since there are 10 guests, we have n is equal to 10. Furthermore, this situation is case 1, since the clockwise and counterclockwise permutations are different. Thus, we will use the formula permutation is equal to n minus 1 factorial. Finally, permutation is equal to 10 minus 1 factorial, which is equal to 9 factorial. And when we expand 9 factorial, we will come up to an answer of 362,000 880. Therefore, there are 362,880 different circular permutations. Let's have the second example. In how many ways can 7 different beads be arranged in a necklace? Since there are 7 beads, we have n is equal to 7. Furthermore, this situation is under case number 2. Since the clockwise and counterclockwise permutations are not different. So the necklace can be flipped, thus we use n minus 1 factorial over 2. Finally, the permutation of n minus 1 factorial over 2 is equal now to 7 minus 1 factorial over 2 or equal to 6 factorial over 2. When we expand 6 factorial, we will come up to 6 times 5 times 4 times 3 times 2 times 1. And the answer will be simplified to 360. Therefore, there are 360 different circular permutations in this problem. So it's about time to test yourself. I prepared 2 problems in this exercise. I hope you can answer it all. Each problem will be given 10 seconds to answer. The timer starts now. Let's try to check if your answers are correct. In the first problem, 8 ladies are to be seated around the table. In how many ways can they occupy their seats? In this first problem, this is under case number 1. Rn is equal to 8, where P is equal to 8 minus 1 factorial, or equal to 7 factorial. Therefore, the answer here is 5,040 ways. Let's have the second problem. In the second problem, there are 10 keys in a ring. In how many ways can they be arranged? This fall in case number 2. Rn is equal to 10. Since this is under case number 2, we will use n minus 1 factorial over 2. And when we substitute the values, 10 minus 1 factorial over 2 is equal to 9 factorial over 2 or 181,440 ways.